All right, everyone, this is our last lesson dealing directly with right triangle trig. We're going to take what we've learned about setting up and solving trig equations and apply it to some real-world examples. And so to start, we need to review some terms that you may or may not have heard before. And these two terms are probably the most commonly used applications with right triangle trig in a real world sense. And so they are angles of elevation and angles of depression. And so if we talk about an angle of depression, so if you look at the picture that's in front of you, if I have a horizontal line, which I'm highlighting here in blue, so I have this horizontal line, and if I look downwards, and so when I look down, my new line of sight is this line I'm highlighting in blue. The angle that's formed between the horizontal line and my new line of sight in which I'm looking down is called my angle of depression. And then an angle of elevation kind of works the same way, where you have some sort of horizontal line. And from that horizontal line, you now direct your line of sight to go upwards. And so the angle that's between the horizontal line and your upwards line of sight is an angle of elevation. And so in this particular example, one thing to be mindful of, and you'll see it as we start doing some problems, is we know that two horizontal lines are going to be parallel to each other. And so in this case, if I think of my line of sight, would essentially be a transversal line. In this particular example, this angle of depression and this angle of elevation are what we would consider alternate interior angles. And we know alternate interior angles are congruent. So sometimes when we start looking at problems, the angle of elevation or depression might be outside of the triangle, but we can use alternate interior angles to bring that angle of elevation or depression to one of the angles that are specifically in a triangle in order to use to set up and solve using right triangle trig. So if you look at example 1, we're just going to do a quick classifying. So if I look at angle 6 here, angle 6, this would be considered an angle of depression, because if I look at my horizontal line here, and then here is my line of sight, I'm having to look downwards from that horizontal line. In angle 7, here is my horizontal line, and from the horizontal line, my line of sight is now going upwards, and so this angle here is an angle of elevation. And then for angle 8, this one would be an angle of depression, because I have my horizontal line, and then I'm looking downwards towards the feet of the statue. And these two are not necessarily congruent to each other, so I'm going to give them a different marking. Whereas 6 and 7 would be congruent because you have two parallel lines and your line of sight is a transversal line. And then, so if angle 8 is an angle of depression, angle 9, so here's my horizontal line, and my line of sight is going upwards, and so this is an angle of elevation. And angles 8 and 9 would be congruent, because if these are my two horizontal lines right here, this line of sight counts as the transversal, making 8 and 9 alternate interior angles. Okay, so let's start applying some problems and actually do some right triangle trig equations. So for example 2, it says a golfer is standing at a tee and he's looking up to a green on a hill. If the tee is 36 yards lower than the green, so this right here, and the angle of elevation from the tee, so the tee is going to be over here, to the hole is 12 degrees. So this angle here is 12. The question is, find the distance from the tee to the hole, and here's the hole. So I'm being asked to find this distance right here. And so this right here, you can see we have a right triangle, and I only know one side. I'm being asked to find another side, so I don't have enough to use Pythagorean theorem, and so this is where my trig ratios come into play. And so when I think about 12 being my angle of reference, 36 would be my opposite side, and then x is the hypotenuse. And so I have the opposite and the hypotenuse, which means I need to use a sine ratio. So I could say that the sine of 12 degrees equals 36, which is the opposite side, over the hypotenuse, which we will say is x. And then I can solve this equation by cross multiplying. So I get x of 12 degrees equals 36. Divide by the sine of 12. And so x is about, and this is where you got to use your calculator because you can't do this one in your head. So 36 divided by the sine of 12 is about 173 yards. So in example 2, this one was kind of nice because we had a picture. We just had to recognize like which part of the triangle we were trying to solve for. If you flip the page and you look at example 3 now, we don't have a picture. And so this is where you're going to want to draw a picture. So you're going to want to try and pull out the piece of information that's going on to set up a triangle so you can kind of see what's going on and then which side you're actually solving for. So this one says an air traffic controller at an airport sights a plane at an angle of elevation of 41 degrees. So if we think about a plane, we know a plane is somewhere, up in the air. And we have the airport controller. So we'll just say it's this person right here. I'll just draw a little picture. And it says that the angle of elevation is 41 degrees. So he is looking upwards from his original horizontal line. Okay. So this is going to be my right triangle. And we know the angle of elevation is 41 degrees. It says the pilot reports that the plane's altitude is 4,000 feet. So altitude is the height. So what they're really telling us is this right here is 4,000 feet. So it says what's the horizontal distance between the plane and the airport? So if we think about it, we've got the air traffic controller. He's here at the airport. Okay, and it asks for the horizontal distance. So the horizontal distance is essentially this part right here. I'm kind of doing a wavy line. So that's going to be our x. And so when I look at the sides that I'm given and I think about my reference angle of 41 degrees, I have the opposite side and the adjacent side, which means I need to use a tangent ratio. So I have the tangent of 41 degrees equals the opposite side of 4,000 over the adjacent side, which is x. So if I cross multiply, and then to solve, I would have to divide by the tangent of 41 degrees. And so x is about, and it says to round to the nearest foot, so essentially round to the nearest whole number. And so when I type this in, I get that the horizontal distance is about 4,601 feet. All right, so we're going to do one more. And this last one I want to do is kind of where I had mentioned earlier that sometimes your angle of elevation or depression may actually not be inside your triangle, but you can use the fact that you have a pair of alternate interior angles to bring the angle that's outside the triangle into the triangle. And so in this last example, it says we have a forest ranger in a 90-foot observation tower sees a fire, and the angle of depression to the fire is 7 degrees. So this person is, sitting here in this observation tower, and so this is the horizontal line, and he has to look down towards the fire. And so when he looks down towards the fire, it creates that 7-degree angle. But if you look at this, I'm being asked to find what's the horizontal distance between the tower and the fire. But right now, all I have in terms of that right triangle is the 90 degrees. I don't have any other information. I don't have the length of SF. I don't have any angles, but this horizontal line that I drew and the bottom of the triangle is also horizontal, meaning they are parallel. And so the line of sight, this diagonal line, is basically a transversal. And so this 7-degree angle and this angle right here are going to be alternate interior angles. So this angle is also 7 degrees. And so now I have an angle inside of my triangle that I can use to set up an equation and solve. And so with 7 as my reference angle, I have the opposite side, and then I'm being asked to find the adjacent side. So this is going to be a tangent ratio. So I have the tangent of 7 equals 90 over x. and then cross multiply and divide by the tangent of 7. And so we're being asked to find the distance, and we're going to round to the nearest foot, so essentially the nearest whole number. And so we get that the horizontal distance is about 733 feet.